Hello. Yes. Okay. Hi everyone. Thanks for coming to this talk. I'm Thiery. I'm a researcher that works at the Robust Incentives Group, which is a group at the Ethereum Foundation that's focused on mechanism design and economic incentives around the Ethereum protocol. And today, my talk will focus on the state of the Ethereum supply network. Okay, so first, for those who haven't been to other MEV talks, I'll just start with some key concepts and definitions. The first one, everyone has their own definition, but MEV, or maximal extractable value, can be just considered as the excess value that can be extracted by adjusting the execution of users' transactions. And by adjusting, I mean reordering or adding or removing transactions. And this is usually done to, this reordering of transactions is usually done to extract some value that is often kind of generated by market inefficiencies. So an example is an arbitrage. And this kind of power is usually given to validators. But we'll see that there are some subtleties that were introduced with PBS and with other actors coming in. So PBS, or proposer-builder separation, was introduced with the merge as kind of a concept, but also like an actual novel protocol feature. And it's designed to preserve decentralization amongst the Ethereum validators. So what it does is basically effectively distinguishes the role of block production that is now dedicated to block builders, and the role of block proposal that is now handled by block proposers. And block proposers are just validators that are randomly selected every slot to propose a block to the rest of the peer-to-peer network. And so, yeah, this change kind of shifts the burden out of the proposer's hands. Because now, like, all the kind of computationally intensive MEV extraction strategies can just be done by the builders. So validators just have to basically get there and pick a bid and propose the block to the rest of the network, and that's that's not very computationally expensive. But the thing is that proposers are still the ones with the ability to reorder and incorporate like additional transactions after they receive blocks from builders. So if we just keep it that way, it doesn't really work. So there was a need to introduce a new piece. And so basically to protect builders from MEV theft or like strategy appropriation, the Ethereum and Flashbots researcher introduced Mathboost. And Mathboost is like an out-of-protocol software that kind of basically allows block proposers to access a marketplace of blocks from a builder marketplace here. And that's done through trusted intermediaries or trusted third parties that we call relays. And so here it basically, how it works, you have the builders that are participating in an auction. We call that a Mathboost auction. And they submit EVM valid blocks and their associated bids. And the bids value are based on the priority fees and the MEV that was extracted from the user's transactions. And so they submit it over the course of a block. You can see that it's usually increasing. And the relay just kind of, well, it used to validate blocks, but now it really doesn't for some. But basically what it does is like it makes those available to proposers. And proposers at the end of the slot, so around 12 seconds, will just like choose the highest bid and commit to it by signing it. And that fact that they sign it is cool because that means like they can't like build another block. Otherwise they will be equivocating, and that's slashable. So once it's signed, basically the block payload is released to the rest of the network and it's propagated. And so this kind of mechanism with the relay kind of ensures that proposers can't steal the content of a block builder. But it does rely like on trusted third parties that are relays. So we'll see that some research is like kind of targeted at looking into ways to get rid of relays in the future, and enshrining, that's what we mean by enshrining PBS in protocol. Okay, but this is only part of the story. And there are like many other parties and mechanisms involved in like whether like it's consuming or producing resources in the block space market, but also like generating and extracting MEV. And that goes basically from users to proposers. So in a post that was written by Stéphane Gosselin last year, he proposed like a mental model to understand the chain of events for the whole kind of block space market from users to proposers. And so it starts like this. I was almost afraid to use the word intent there, but users start with an intent, like I want to swap ETH for USDC. And then they connect to a dApp like Uniswap via their wallets. And basically then they sign a transaction to execute the swap. And this transaction is usually made available in a global topic that's called the mempool. And it's pending, and it's basically waiting to be included in a block. So what searchers do is they look at these pending transactions, and they reorder them so they can extract MEV from them. And that materializes into bundles, so there are like sets of atomic transactions. That, so what they do is like they make bundles, they take a cut, because they have to get paid, and then they forward the bundles to the block builders. And in principle, the block builders just has to take those bundles and pack them together, in addition to all the transactions in the mempool that weren't necessarily generating MEV. And so builders construct full blocks, and then they participate in the Mathboost auction that I just mentioned before, so the whole interplay between relays, proposers, and builders. So hopefully, I've conveyed how this mental model of the supply chain is helpful to understand how things work. But since PBS was introduced, things have changed quite quickly. And like there was kind of an explosion of innovations and protocols and experiments that have popped up around block space production and allocation and MEV extraction. And this, in our opinion, motivates like a shift of mental model from the MEV supply chain that I just talked about to an MEV supply network. And yeah, when we were discussing this with other like ring members, we looked up the definition of a supply network on Wikipedia, and just with changing a few words, it kind of made sense. So an Ethereum supply network might be defined as a pattern of temporal and spatial processes that are carried out at facility nodes and over distribution links, which adds value for users through the manufacturing and delivery of block space. Okay, so maybe an updated picture for the state of the Ethereum supply network as it is looks like this now. This is a lot, but it's not exhaustive at all. There are like really tons of things happening in that space because it's all out of protocol, so everyone can just innovate, and they do. So I thought it would just be interesting to add some research topics and resources that are associated with the new boxes I've added to the figure. So the first one is OFAs, or order flow auctions. So here it's actually cool. It's like basically OFAs allow users to directly send their transactions to dedicated mempool via like a custom RPC. And in that dedicated mempool, you have solvers and searchers that compete for the right to extract MEV opportunities. But you can implement new features like programmable privacy. So for example, users can choose to share or not some elements of their transactions. And you can also, like, another cool feature is like choosing how you want to redistribute MEV. So there was this big thing about MEV rebates, in which some of the value that was generated, so the MEV is actually rebated back to the user for whose transaction was actually generating MEV. Another interesting thing to look at in the future, I haven't seen too much research on this, but it's account abstraction. And well, no, account abstraction is there is some research, but like the role it plays in MEV a bit less. So account abstraction is, and its implementation via like this new standard of ERC 4337 is worth looking at in terms of what role it will play in this MEV supply network. And I'm kind of interested on how mempool fragmentation, so the way basically you'll have like a lot of alternative mempool that will pop up, how this will have a role, and maybe we can look into this. Then I added a Swapbox. So it's not live yet, but there were some recent announcements by Flashbots, and I expect there will be a bit more maybe this week. And like the idea here is to propose like an end-to-end, so end-to-end is user to proposer chain that's like dedicated to MEV, and that's trying to decentralize the whole block building process. Yeah, so that's the idea. I've also added Eigen Layer. So this, so Eigen Layer, I guess, is live on mainnet, but like the applications are not. But basically, it enables validators to restake their ETH and perform extra duties or offer extract services, and we can expect some of these services will be directly targeted to MEV extraction or block space prediction. And this is in exchange for additional protocol fees and rewards. And they have a proposal, I think, specifically on that, on like partial block Mathboost building through Eigen Layer, if you want to check it out. And then you have all the MEV-aware dApps. You have the existing co-swap, but also like it might be interesting to see in the future what people can do with Uniswap hooks regarding MEV. And so, yeah, my last part is maybe closer to what we've been focusing on at the rig. Yeah, at the rig, we've focused mostly on this part. I guess it's also the part that's closer to proposer, so closer to the protocol. And I thought it would be a good opportunity to mention a few examples of what we've been working on. So the first example is research led by Caspar here on timing games. We got an article that got accepted at SBC, so I've linked it here. All the blue underlined captions are actually links, so if you want to check it out after the presentation, that's a way to do that. And yeah, this line of research focuses on basically players, proposers that play a timing game, which means before, I said around 12 seconds, proposers can just choose a block and propose it to the rest of the network, and they can play the game of just waiting a bit longer, so they can accumulate more MEV and earn more rewards, because MEV is increasing linearly with time. And so it's interesting in itself, but also it introduces a way vaster, like larger, high-level questions of whether consensus protocols and designs, in addition to the usual liveness and finality concerns, also need to take into account economic fairness. So that's, again, research that I think is super interesting. Another very important line of research is EPWS design. So I've mentioned there is ways of trying to enshrine PBS and Mathboost auctions and getting rid of relays to have this in the Ethereum protocol. And this is research Barnaby with Pepsi, but also Mike, Justin, and Francesco have been very active on. You have a very kind of implementation security focused roadmap. I'm trying to speed that up because I'm very late. And then, yeah, something I've been very interested in is on the more, I guess, modeling simulations part of things, to try to simulate Mathboost auctions out there now, and to try to tweak the parameters and to look at builder strategies and what they are using as bidding strategies. So we can try to design auctions that are suited for what we need, which means avoid centralization, minimize the risk of people using side channels because our mechanism is actually not good enough and everything. So that's a kind of simulations, empirical modeling approach. And there is another more formal approach that Julian has been leading, but also with Davide and Barnabe, that is looking as more like theoretical and formal models of PBS. And I think there are like some great insights to learn from that too. And I don't have time to get too into it, but Pepsi is a way more general kind of a way of, oh, I'm getting science, like hardcore science. Okay, check out Pepsi, it's very cool. The takeaways, I'm going to be very quick here, but basically, I think thinking of the Ethereum, like the Ethereum supply network is important because it helps like understanding all the interconnected parties that are interacting together. It can probably also be a natural applied path to analyzing the network as a network, like as a complex system, maybe using like metrics that are suited for it, so graph theoretical analysis and so on. And also I just wanted to like shield research on the MEV supply network because it's super broad. It spans like various research domains. And so we have rig open problems which are specifically dedicated to researchers that want to contribute and collaborate with us. So feel free to check it out and come to us afterwards. And the rig homepage where you can find all our posts, papers, and talks. Thank you.